Hey everyone, Ryan here. So I'm just jumping on to discuss a question I was asked from Andrew in the Facebook group concerning this idea of foot pressure, the direction of push, the location of push, mainly within the context of this iso lunge position that we discussed at the end of module 2. So I want to use this slide here to discuss this, and then we'll jump into this iso lunge position and kind of discuss this in a bit more detail, but we'll probably do a little bit of both. So in general, what we're talking about here is the manipulation of moment arms. Now, a moment arm is the perpendicular distance between the line of action, or within the context of what we're going to talk about, the external force vector that moves through our body. The perpendicular distance between that vector of force and the joint axis of rotation, because what this will influence is the torque generated at a joint, which is a turning action. Okay, so I'll actually jump straight into this lunge position here. So let's say, for example, I'm pushing down into the ground via my midfoot, just the middle of the foot. That's going to create then a counteracting ground reaction force. When I'm pushing into the ground is going to push back up against me. And that's a ground reaction force. And that will create an external force vector that moves through my body. Okay. That ground reaction force vector will enter through the system. Now, naturally, in the real world situation, these ground reaction force vectors are moving all over the body. What we're trying to do when we talk about being specific with how we're organizing joints and organizing muscular contractions is we're actually being specific about how we're manipulating these moment arms. So for example, when I'm pushing down through the midfoot, this creates a ground reaction force that moves up. We have to consider the perpendicular distance between that external force vector and the knee joint and the hip joint. So you can consider the distance between that force vector and the hip and the distance between the force vector and the knee. Which joint do you think it's going to be challenging most here? It's going to be challenging the hip joint more, because the distance between that ground reaction force vector and the hip joint is much larger. It's much smaller between the force vector and the knee joint. Okay. Now, what's important to understand here is how that force vector enters the system relative to the joints. So because it's entering behind the knee joint, that ground reaction force vector is going to create an external, because the ground reaction force is an external force. A muscular contraction is an internal force. And so because it passes behind the knee, it's going to create an external knee flexion moment, meaning that ground reaction force vector is trying to flex the knee, which means the knee extensors, the quadriceps, will have to generate an internal force to counteract that external force. And because that ground reaction force vector enters in front of the hip, it's going to try to flex the hip. It's going to create an external knee or hip flexion moment, which means the hip extensors will have to generate an extension moment to counteract that, an internal extension moment to counteract that external force, that external hip flexion moment. Okay. Now, what's interesting here is how we can manipulate this. So let's say, for example, if this is my first time using these arrows here. So let's say, for example, I change the direction of my push. Let's say I'm pushing down and back. Okay, so that's going to create then a ground reaction force vector that moves in this direction. Okay, now you can see that runs parallel to the shin now. Okay, so think of the distance between that external force vector now and the knee. It's essentially traveling right through the knee joint. So it's going to put much less demand on the knee. But I've just increased the distance between that external force vector and the hip joint. So I'm going to increase the challenge on the hip extensors just by manipulating the direction of my push. Okay. Now, if I was to, for example, push straight back, let's say I'm dropping into a forward lunge, for example, and I push down and forward. Or not down and forward, but I'm pushing down and back. I'm pushing my body back the way, right? So I'm pushing down. Well, essentially, I am pushing down and forward to project my body upwards, and backwards. So it's going to create a ground reaction force vector, let's say in this direction here, okay? Now, the external force vector is moving closer to the hip joint, but it's much farther now from the knee joint, the perpendicular distance here. So that's going to increase the external knee flexion moment arm, and it's going to request a lot more demand from the quadriceps. It's going to require the quadriceps to do more, okay? So that's a little bit about the direction of the push, okay? So you'll see this here. If I push down and forward to project my body back, that's going to increase the quadricep internal demand. And if I push down and back, I'm going to get less quads, more calves, and more hip. Because, for example, if I was to push down and forward, that's going to travel closer to the ankle joint. If I was to push down and back, let's say through the forefoot in this direction, to try and project my body forward, it's going to increase the distance between the external force vector, the ground reaction force vector, and the ankle joint. And that's generally why you see in the research when we jump forward, you're going to see a lot more demand from the hip extensors and the ankle plantarflexors and less demand from the quadriceps. When you push straight up, you're going to get a little bit of everything. You're going to get hips, quads, and ankle plantarflexors. When you push backwards, or if you're landing from a forward jump, for example, you're going to get a lot less hip, a lot less plantarflexor, and a lot more quads. So let's briefly talk about the foot pressure here. Okay. Now I'm a big fan of manipulating foot pressure, but